right, number one.
How fast must a truck travel to stay beneath an airplane that is moving 105 kilometers per hour at an angle of 25 degrees to the ground? Now, one of the things that you're going to want to make the habit of doing, and I hope I've made this case to you before, that drawing your triangle is the single hardest thing you have to do on these types of problems. Okay, and I mean that. So we have a vector. This is going to be, what is it? This is a velocity. The velocity, draw my vector. So this is my 105 kilometers per hour. Okay. And then what I'm being asked is, what is the x component of that velocity? Okay. How fast must a truck travel to stay beneath an airplane? So using your common sense, you guys know that a truck is going to travel in the horizontal direction, not the vertical direction. And so to stay directly underneath the plane as it moves, that's simply the horizontal component of the velocity. Now notice I have constructed myself a right triangle. Don't say that it's not perfect, because it's totally perfect. And I know that my velocity is 105 kilometers per hour, and my theta, 25 degrees. Now, for the drawing of this triangle, I am going to suggest to you that you take the items that I've suggested that you write over in the side, kind of like as a bank of things that you know. I'm going to suggest that you actually write those into your triangle. Right, so this resultant vector, right, the velocity of the airplane, I'm actually going to draw that on the hypotenuse. And then the angle to the ground, I'm actually going to identify which angle of the triangle I'm actually referring to. If you do that, and here's the reason why you do something so simple, right? So simple as to write the angle twice. When I go to use my rules for, my SOHCAHTOA rules, these always are from the perspective of a specific angle. Okay? And you can pick the wrong angle and the perspective that goes along with it. So if I draw in my diagram, my vector diagram, that this is the angle that I'm starting from, it's very easy for me to choose which one of these functions to use, sine, cosine, or tangent. Now, I'm supposed to be solving for the horizontal component of the velocity. And so if this is the angle that I'm starting at, this is the adjacent side. Okay? The adjacent side. So that tells me that I'm going to use cosine, because the cosine of any angle is equal to the adjacent side divided by the hypotenuse. Okay? Now let me ask you, when I was in school, this is how we approach triangles. Do you guys still approach triangles this way in math class these days? Or do they approach it a different way? You do? Okay. All right. I'm getting old. Sometimes they don't do it the same way they did when I was in school. Oh, we're getting unfocused. Was that The Incredibles 2, where they came up with like a new type of math? Mr. Incredible is getting all mad. And he's like, it worked before. Why did you need new math? All right, so in this situation, I am solving for the adjacent side. So I'm going to algebraically rearrange this. So the adjacent side is equal to the hypotenuse multiplied by the cosine of theta. So it's going to be 105 kilometers per hour multiplied by the cosine of 25 degrees, which comes out to be, I'm running out of room, Now, do I need to include a direction? Why not? So, yep, it just says how fast. It's just the speed. It's not saying what is the velocity. Just what is, or sorry, how fast. So no direction. You're good.